Hello and welcome to Think Python, Chapter 2, Part 1. As always, you can use this link, thinkpython.com/nb, to get to this page, which has all of the notebooks. We're going to click here to run Chapter 2 on Colab. The first thing you'll want to do is press this button, Copy to Drive, to make a copy of the notebook in your Google Drive, so that when you come back to it later, it'll still be there. Once the notebook loads, the first thing we'll do is run this cell to download thinkpython.py, which is the module we've used before, and diagram.py, which is new. I'll show you what that does in just a minute. You can run this cell by holding down Shift and pressing Enter. That'll take just a couple of seconds to load. And then we'll start in with variables and statements. In the last notebook, we did some computations, but we weren't able to save the results. So if we wanted to use the result from a previous computation, we would have to type it again. Variables solve that problem. A variable is a name that you can assign to a value. So, for example, if you type n equals 17, that creates a new variable named n, and it assigns it the value 17, which is an integer. You can also create variables that contain floating point numbers. So, for example, we could write pi equals 3.14159, and that creates the variable pi and assigns it that value. The value of a variable can also be a string. So if we have a variable named message, we can assign it a string like "and now" for something completely different. And again, that creates the variable named message and assigns it that value, which is a string. When you assign a value to a variable, it doesn't have any visible effect. But later you can display the value of that variable by using the name of the variable as an expression. And the value of that expression in this case is that string, and now for something completely different. You can also use a variable as a part of an expression along with arithmetic operations. So for example, n plus 25 has the value 42, or 2 times pi has the value roughly 6.28. You can also use a variable when you call a function. So for example, we can call the round function and pass the variable pi as an argument. And pi rounded off to the nearest integer is about 3. Or we could use the length function, len, and pass message as an argument. And the result is the length of that string, which is 42. A state diagram is a graphical way to represent variables and their values. There's some code here that generates a state diagram. It uses features that we haven't seen before, so you don't have to understand this code. But if you execute this cell and the following one, it shows this diagram, which shows each of the variables, n, pi, and message, and their values, 17, 3.14, and now for something completely different. This is called a state diagram because it shows the state of each variable, which you can think of as its state of mind, what value it currently holds. In general, when you create a variable, you can give it any name you like. You can use uppercase and lowercase letters. You can use numbers, but you can't have a number at the beginning of a variable name. And you can use an underscore character, but other than that, you can't use any other punctuation. So, for example, if you have million with an exclamation point at the end, that's illegal because exclamation point is not legal punctuation. If you have a variable like 76 trombones, that's not legal because there's a digit at the beginning of that variable name. There's one other example, like class, which seems like it should be a perfectly good variable name. It's all lowercase letters, no number at the beginning, no punctuation. But it turns out that's not legal because class is a keyword, which is a special word that Python uses to identify the structure of a program. We'll see later on what the class keyword does, But for now, you should know that you can't use it as a variable name. I've given you a list here of all the keywords in Python. So none of these are legal as variable names. But you don't have to memorize this list. What you might notice when you type a keyword in a development environment like Colab is it's colored blue, and that's a hint that it's a Python keyword. So you'll see that, or you'll get an error message, and gradually you'll remember which of these keywords you can't use as variable names. In order to use some Python features, you have to import them first. So for example, there's a math module, which we can import like this, and it provides a collection of variables and functions that we can use. So for example, in the math module, there's a variable named pi, and it has the approximate value of pi. Notice that I use the dot operator to separate the name of the module, which is math, from the name of the variable, which is pi. The math module also provides functions that compute mathematical operations. So for example, math.sqrt computes square roots. If we give it an argument like 25, the square root of 25 is 5. The math module also provides a function that's called pow that computes powers. It raises the first number, like 5, to the power of the second number, like 2. And that result is 25. Now, you might remember that we've already seen an operator that does exponentiation, which is the star operator. So either one of those is fine. It's more common to use the operator star. At this point, we've seen a couple of kinds of expressions and a couple of kinds of statements. So I want to review what we've seen so far. An expression can be a single value, like an integer, floating point number, or a string. It can also be a variable name, or it can be a collection of operators and operands. So, for example, we could write a number like 19, and then add in a variable like n, and add in a function call like round, where we pass as an argument math.pi, and we can have other arithmetic operations like multiplication, and the result is 42. At this point, we've also seen several kinds of statements. So for example, an assignment statement assigns a value to a variable, but the statement itself doesn't have a value, and so it doesn't display anything. Similarly, an import statement has the effect of making a module available for us to use, but the statement itself doesn't have a value. So this is a useful distinction between an expression, which has a value, and finding that value is called evaluation, and a statement which has an effect but doesn't have a value, and running a statement is called execution. We'll stop there for now. In part 2, we'll come back and learn about the print function.